All right, everybody, welcome to our analytical geometry session. This one topic is one topic that is very, very important, beautiful to do, and grade 11s. This is going to be a continuation from grade 10, and for grade 12s, this you'll find in question 3. For grade 12, you have 2 analytical questions. Question 3 in your paper 2 will be grade 11 work, and question 4 will be grade 12 work. So it's grade 11 and grade 12. I am not focusing on you grade 12s. I am focusing on my grade 11s. So I'm going to work at their pace. Okay? I am going to work at their pace, and which will be an advantage for you. So there are some things that you might have learned, but don't worry. It's good revision. So that when we get to our grade 12 concept, I don't have to do grade 11 again. Okay, quickly. We are going to talk about analytical geometry, which is all referring to coordinates. And when we say coordinate, it is always X and Y. Quickly, X and Y. And quickly, since we're talking about coordinates, let's deal with this quickly. Just a quick reminder of where our X and Y values are. Positive X, negative X, positive Y, and negative Y. Now, the most important thing here is to know how to calculate the different concepts. And for today, concept number 1, let's say the gradient concept. I am going to mention 6 important things on gradients. 6 important things on gradient. What is the symbol for gradient? Small letter M. Symbol for gradient is small letter M. This is grade 10 so far. Types of gradient. We are going to have that. We would have that. We would have that. And we would have that. A, B, C, and D. Gradient is greater than 0, positive. And we will call this an increasing gradient. Gradient is less than 0. We are saying our gradient is a negative answer. And this is decreasing gradient. Gradient is undefined. We will see why this is undefined shortly. And gradient here is equal to 0. It's a horizontal line. Oh, by the way, let's put this is a vertical line. So the gradient of a vertical line is undefined, while the gradient of a horizontal line is 0. So this is my first introduction, gradient. The meaning of gradient, we could say how steep. We can just put this, gradient. How steep 2 points are to each other. Whether physics or chemistry, this is also very important. Okay, are we good, everybody? I want to move as quickly as possible. Please make sure you go with me slide by slide. Don't get lost at all. Types of gradient, we have 4 types: increasing, decreasing, undefined, and horizontal. 0 gradient. Here we can, okay, fine. Let's just leave it like this. Now we are going to look at different representation. Rosemary, take a screenshot quickly. You just came in, take a screenshot, or somebody on each group take a screenshot. I have 3 groups here. A screenshot quickly, 1 per group, and just send it so that people who come late can join or can have the notes. The notes are very important. I'm waiting to see messages on my phone. Someone should please just take ta. 1 on each group. Don't wait for someone. Even if 5 of you take it and send it, not a problem. 15 seconds. I'm going to move. Thank you. I already see 1. Okay. All right, 1 more group. Is that group here? Let me see. Yeah, Sipati, you're here, so that group should be here. Okay, guys, let's move. I don't really have time. Now, what are the concepts of gradients that I need us to find? We are on gradient, so number 1. Y is equal to mx plus c. Okay, let's label this equation of a line. Number 1, equation of a line. So we can find our gradient there. Equation of a line. I'll give you an example. If y equals to 2x plus 5, what is my gradient? The coefficient of x. My gradient is 2. My gradient is 2. I am given this, and I want to find my gradient. I cannot find gradient until I write it as y equals to, so I need to make y the subject. Let's take everything over. 3y equals to negative 2x plus 2. Now let's divide by 3. I'm dividing everything by 3. So what is my gradient? Let me know if we are okay. I'm done with my first one. I said about 6 that I want to look at. I'm done with my first one, equation of a line. You cannot get the gradient until you write it as y is equal to mx plus c. You must first write it as the equation of a line. Let me know if you are lost page by page. No one is lost here. Everybody is good. So we can carry on. That is number 1. Done. Number 2. The rate of change. So gradient will be what? Change in y over change in x. y2 minus y1. This is if I am given 2 coordinates. So example, given coordinate of A, 2 and 5, and the coordinate of B, 0 and negative 2. Find the gradient. between those 2 points. If I am given 2 coordinates, then I'll come and say, oh, it's changing y, and please look at what I'm going to do. I'm going to use a and b. You don't have to use 1 and 2. I like a and b. ya minus yb over xa minus xb. And we said coordinate x first, y follow. X first, that's the standard. Oh, beautiful. So if I write it, please take note. Don't write ya minus yb, and then when you get to the bottom, you change it and say xb minus xa. You'll get a wrong answer. If it is a first on top, it must be a first at the bottom. We will try to do something now. So please, I'm using AB. Or I can use, if I'm writing b first, on top, b minus a. When I come to the bottom, I must also have it as b minus a. That is very, very important. Okay, what is the y value of b? So I'll go to my b. My y value is y value of a, 5, minus, what is the y value of b? -2 over x value of a, because it's ab. X value of a is 2 minus, what is the x value of b? 0. Minus would give us plus, so that is what? 7 over 2. 7 over 2. If I use the second one, b and a, now b first. What is my y value of b? -2 minus, what's the y value of a? 5 over x value of b? 0 minus 2. -7 over -2. Do you see my answers are the same? So if it is a first, you get a on top. A must also begin at the bottom. Please, let's write as quickly as possible, and you give me an answer to this. Find the gradient between P and Q. Gradient between P and Q. Get me answers? I'm seeing -7 over 3. Is that correct? All right, quickly, I would write it as yp minus yq over xp minus xq. What is the y value of p? -3 minus the y value of q, 4, over x value of p, 3, minus x value of q. All right, you guys are correct. We move. Number 3. So y equals to mx plus c, number 1. Number 2, the rate of change. Number 3, tan angle of inclination. This is the new one in grade 11. You didn't do this in grade 10. All right. Tan theta is equal to m. But let's define theta. It's called the angle of inclination measured anti-clockwise from the x-axis. And we are going to do 2 of them. Just 2 basically. One, I'll draw it as an increasing, and the second one, I'll draw it as a decreasing. Just hold on writing. I know you want to write. I am measuring from the x-axis anti-clockwise, so that is my theta. I am measuring from the x-axis anti-clockwise, that is my theta. You would notice here, gradient is greater than 0. Theta will be less than 90. Acute. Gradient is less than 0. Theta will be greater than 90. Let's do this. Theta will be between 90 and what? 180. And you would notice we are going back to trigonometry. First quadrant and second quadrant. We're going to look at examples of this quickly. Yes, talk to me. Is there a hand? Hi, Specitly. Okay, I want us to quickly look at one example each. And how to work around this. Everybody done writing? Okay, let's look at a quick example here on point number 3. We are going to calculate gradient for 2 lines. And I'll show you where examiners want to catch you on this thing here. Oh, let me do this. Yeah, beautiful. I just thought of something now. Let's do it at once. So look at this. Examiners are going to have something like that. Okay, we're going to have something like that. A, B, and C. We're going to have theta here. All right. We're going to have alpha here. And we're going to have beta here. Okay, those are just variables. So that I say tan theta equals to m doesn't mean this theta, it's just a variable there. Let's have this coordinate of this point as -1 and -7. Coordinate of this point as, let's say, that is +3 and 7. And point A, let's have it as -3 and 7. I only have two angles of inclination here. Please draw as quickly as possible. I only have two angles of inclination here, which is alpha and beta. Alpha and beta are the angles of inclination. Do you know why? We measure them from the x-axis. We measure them anti-clockwise from the x. So theta is actually not, let's put this arrow there, from the x, don't forget. But the examiner is going to ask you to find angle theta. And I want to walk through this with you, then give you one to do for me as quickly as possible. Now, if you look at, I have theta, alpha. And alpha is in connection. I'm going to highlight. Alpha, if I check, it's in connection with which line? BC. Once I see angle of inclination, tan alpha, because that's the angle, gradient of BC. Tan alpha is, please, the way you write is important. Why BC? Alpha is connected from the x-axis. Does that make sense to you? Yes, specifically, talk to me. Guys, does that make sense to you? Let me know. Specifically, you raised a hand. I don't know if it's a mistake. Do you understand why I'm using BC there?
Yeah, I'm okay.
Okay. All right, guys, quickly, get me the gradient of BC. Everybody. You are going to do that for me. We're practicing now. Gradient of BC. And I'm expecting my answer to be positive, though, just by the way it looks. Let me know once you are done. I think I am done. Yes? Look at alpha. Look at alpha.
Yeah,
which line is in contact with?
This.
So we said angle of inclination is measured from the x to the line anti-clockwise. So BC. I have a 7/2, and that's the answer I'm getting as well. So we say that tan alpha, okay, let's find gradient of BC first. Gradient of BC, YB minus YC over XB minus XC, which is, what is my YB? Negative 7 minus 7. What is XB? Negative 1 minus 3. And that will give me 14, negative 14 over that, which is 7 over 2. Now, tan alpha, therefore, now is what? Gradient of BC, 7 over 2. What is alpha? Grade 10. Arctan of 7 over 2. Calculators now, we get our answer. Arctan of 7 over 2. 74.05 degrees. I told you that if my gradient is positive, my angle should be less than 0. Oh, thank you. You guys are giving me 74. Beautiful. Everybody okay there? Any question? Let me know. Give me a thumbs down if you feel lost. Ndubu, are you okay?
But I'm getting 82.
You're getting what?
82.28.
Did you press shift 10 on your calculator?
Yes, I did.
Okay, can you press sine 30 on your calculator for me? What is sine 30 on your calculator?
0.89.
Okay, there's something wrong. Let's reset your calculator. Follow my steps. Press shift 9. Do you see it says clear? All right.
Yes.
Then you press, so you want to clear everything. So number 3 is to clear all.
Yes.
There's another method, but this is the one I remember. Are you there?
Yes.
Reset all. It's equal to. This is the one I remember that comes to my head. Press AC. Your calculator is now fine.
Thank you, sir.
Your calculator is now fine. Press sine 30 again on your calculator. You must get 0.5.
Yes, sir.
All right, now press this again now. Arctan 7 over 2.
Yes, sir, I got it.
So if I didn't call you, you're not going to tell me that you're not getting that answer.
No, sir, we were both to do a first together upload it.
Okay, all right. Please let me know so that we move together. We're done there. Now, what about tan beta? What do you think? Which line? Gradient of which line? If you check, measuring from the x-axis to the line, which line are we measuring it to? AB. So my good learners, let's find the gradient of AB. YA minus YB XA. Now, what's the Y value of A? You can go ahead and calculate as well. Y value of B. My answer should be negative though. X value of A is what? Negative 3 minus X value of B, negative 1. What will my answer be? That is 14 over what? 1 minus 3, negative 2. So that should be negative 7. Confirm? All right, great, beautiful. I see a lot of negative 7s coming in. The next thing is, how do I then work around? Please, I need you to listen to this part. I'm going to go back to trigonometry. If you look at this, if you look at my line, we are actually in the second quadrant. If you were to look at this, that's how we measure it. And my reduction is 180 minus reference angle. That's why it's negative. Oh, tan B. Do you notice? Tan is negative in the second quadrant. Please, I'm going to use the trig method. Find your reference angle, which is arctan. Don't put the sign of 7. Find the reference angle without the sign. You see, I didn't write beta, I said reference. Arctan without the sign, please, without the sign. 81,86 or 81,87. But this is only a reference angle. What will my beta be? It's in the second quadrant. 180 minus 81,87. This is very important. It is an obtuse angle, so it must be greater than 90. 98,13. Trigonometry. 98,13. I don't know if we are on the same page.
But don't we use the sign?
Sorry?
Don't we use the sign so negative 7?
Yes, I said when we are looking for reference angle, we don't use the sign. The negative only tells me about the quadrant. I know some of you are taught in school to put in the sign, but I don't like that because I want to maintain one thing. Check. If I put the sign, look at what I'm going to get. I am going to get a negative answer. Shift tan, sorry. That will not be the correct answer. Check. To give me what? That. Do you see that? I'll have to say plus 180. 98,13. But let's go through what we know from trigonometry. Finding general solutions. When you are looking for the reference, make a note for yourself. Reference angle, don't put the sign. Those are the notes that is called study notes. Reference angle, don't put the sign. Sign is for quadrants, to tell you which quadrant you are using. And right now we know we are in the second quadrant because tan is negative in the second quadrant. And the reduction for second quadrant is 180 minus ref, quadrant 2. 180. So this is general solutions again that we are doing. Does that make sense, everybody? Does that make sense? So that we maintain the same system throughout. We maintain the same system throughout. Now, but I'm looking for theta. We can now use our knowledge of triangles to find theta. Are you aware that I can use vertically opposite there, right? Does that make sense? Now I have a triangle that looks like this. Check this. I'm now doing Euclidean geometry. This is beta. This is theta. Now this is alpha because of vertically opposite angles. Grade 8, 9, 10. Do you notice I can get theta now? There are two ways. If it's either I find this angle and say sum of angles in the triangle, or I know this one as an external. So beta would be external angle of a triangle is equal to sum of interior opposites. If you don't remember this, there's no problem. You can just use angles on a straight line. It's just that it's more work. So what is theta? Beta minus alpha. What is my beta? 98,13 minus 74,05. And that will give me my answer there. And I am done. Let me know if that makes sense. You can just do sum of angles in a triangle, but it's just longer. All right. 24,08 degrees. Otherwise, find the angle on a straight line and add the 3 together to get 180. But I need you to learn this. This is always shorter and quicker. Benjamin, how are you? Exterior angle of a triangle is equal to sum of opposite interior. We're going to do more of that as we go on. Everybody okay? This is my point number 3. I have 6 points on gradient. Or 5. So we need to move. Can I go to point number 4, or do I still have someone writing? If you are still writing, just give me a thumbs down. Okay. Point number 4. On gradient. Parallel lines. If two lines are parallel, they have the same gradient. And this is so important. We are going to see properties of shapes. They have the same what? Gradient. If two lines are parallel, then, so for example, you have a square, you have a rectangle, you have a parallelogram, gradient of AB. This is very, very important. Important in shapes like square, rectangle, or parallelograms. I should have actually used that word. In fact, let's just clean all of this. In shapes like parallelograms. Because everything I'm writing, they're all parallelograms. Important in shapes like parallelograms. So you have your square, you have your rectangle, you have your rhombus, anything parallel. Number 5, perpendicular lines. If two lines are perpendicular, that is, angle between them is 90, the product of their gradient is -1. Please, product of their gradients, there are two, is -1. A, B, C, D. perpendicular. It means gradient of AC times the gradient of BD is equal to -1. The product of their gradients is -1. Product of gradient is -1. This is very, very important. Simple way of finding it is to change the sign and reciprocate the gradient of one to get the other one. Example, if the gradient of AB, or in this case AC, let's say the gradient of AC in this case is a positive gradient 2/3, then gradient of BD now this one is a positive, this one has to be a negative. If this is 2/3, then we reciprocate, and that would be 3/2. You don't have to do the times that to give you -1. Now, if gradient of one is 2/3, then the other will be what? -3/2. We just change the sign and reciprocate. Simple way is to change the sign and reciprocate the gradient. Only if the angle between them is 90 degrees. Waiting for us to finish writing. All right, everybody good, done writing? This is point number 5. Then we go to point number 6. And guys, the rest will be grade 10. I promise you. The rest of the story will be grade 10. Distance, midpoint, blah, blah, blah. Okay, point number 6. Collinear points. Collinear refers to collinear refers to points on a straight line. That is, all the points are on a straight line. The gradient between any 2 points, on a straight line are the same. I'm going to have a straight line there, and I have a point. A, B, C. Those points are on a straight line, so they are collinear. What are we saying, therefore? The gradient of AB is the same as the gradient of BC, which is also the same as the gradient of AB. Any 2 points that we can create, gradient would be the same. 6 important points on gradient. No one should struggle on how to find the gradient anymore. We started y equals to mx plus c. We moved to rate of change in y over change in x. We moved to angle of inclination. We moved to parallel lines, perpendicular lines, and collinear points. If the points are the same on a straight line, right, then the gradient between them are the same. Concept number 2. Concepts. Continued. Number 2. Distance. That one, there's nothing. We just throw in our formula. D equals to square root of x2 minus x1 squared plus y2 minus y1 squared. With that, we did this in grade 10. We just throw in our formulas there. Number 2 concept is the concept of distance. Yes, talk to me now, lady. Now, lady, you know what? Okay, it's fine. There's something I could do on this gradient stuff. Okay, but let me finish the concept. All right, now, lady, let me finish this. There's something I wanted to do on gradient. Ooh, it would have been nice if I could do it now, but I don't want it to cancel, but it's fine. Quickly find the distance. I'll finish with what I wanted to do, application. Find the distance between A, 3, 5, and F, 8 and negative 2. Find the distance for me. Just substitute. Share your answers. Okay, give me your answer in short form. Is it root 74, Awande? Root 74. Okay. Quickly, we substitute, right? D will be square root of x2. So this time around, I have a and b, xa minus xb squared plus ya minus yb squared. Always important to write the formula to make my substitution easy. What's the x value of a? 3. X value, oh, I have f, not b. What is the x value of f? 8. Y value of a? 5. Y value of f? Minus 2. Root 74. Done. Distance. Everybody should be okay. Thank you, guys. You see, very straightforward stuff there. I'm moving on. My next concept. Concept 3. Midpoint. Capital M. Please take note. Gradient is small letter m. Capital M. x1 plus x2 over 2. y1 plus y2 over 2. Midpoint. Okay, very important. I'm going to do something very important here. Find me the midpoint of P and Q. -2, -3, 8, and 6. Find the midpoint. I want you to get me the coordinates there. Very simple as well. We just throw in those values, x1 and x2. Start throwing in your values. All right, I see you guys are done with the first one. 3/2. Let's check. Since M is the midpoint, we would simply say M, therefore, is XP plus XQ over 2 YP plus YQ. I like to use the letters I'm given. Makes it very easy to pick my coordinates. What is the X value of P? -2. X value of Q, 8. And that I can quickly do. 8 minus 2 is 6 divided by 2, that's 3. Y value of P, -3. Y value of Q, 6. And that I can do. 6 minus 3 is 3, so I have 3 over 2. We are done. Now, I'm sure we all did that. Look at the second one. Please don't make a mistake. Let us make a lot of mistakes here. The second one, I am now looking for the S, not the midpoint. Guys, you do it the same way and substitute. I know my midpoint as 7 and 4. Oh, wait. The X midpoint, capital M, should be what? XR plus XS over 2. Question is, do I know my XM? Yes, 7. What is XR? 5. I do not know this one. Over 2. Cross multiply, 14. 5 plus XS equals to 14. What is that value? 14 minus 5 would give me what? 9. Then the same thing. Y midpoint is YR plus YS over 2. What is the Y midpoint? 4. YR 8 plus YS over 2. What do I have? Ta-na-na-na-na-na-na. What's it going to be? 8 equals to 8 plus YS. So what is the Y value of S? 0. So what is S? 9. Let me know if we are on the same page with that. We're all on the same page. So we're doing all of these little things. We are going to then combine them in a question. I only have about 3 more things to tell you. 3 more. And then we jump into questions. So I'm going to try to push the 3 in next 15 minutes. And then I give you a question to try at home. Okay? We'll then mark next week and we're done. We move to our next concept. So we have 1 day of full activity. Can I move? And then we apply. There's some things I want us to apply. Awesome. Concept number 4. Point of intersection. We go back to function. To find the coordinate of the point of intersection. Oh, there's something I need to, okay, I'll do that after this. I should have done this now. Find the coordinate of point of intersection we equate the 2 equations. That is, solve simultaneously. So we equate to solve simultaneously. Let's just try one. I'm just going to create something. Y equals to 2x plus 4. And then I have another line here that says y equals to negative x plus 4. Let's find the coordinate. Ooh, I hope my equations are going to work. Just give me a second before you write these equations in case I need to change. Yeah, but I think they would work. But I don't want, okay, it's fine. Yeah, it's fine. Point A. The lines are touching at point A. Point A becomes my point of intersection. And all I need to do is to equate to get my x and y. Just put this for me. At the point of intersection, both lines have the same value. Both lines have the same coordinates. So their x and y values are the same. Their x and y values are the same. X and y values are the same. There's something I want to teach you once we're done. I have two more things to tell you on this. No, one more thing to tell you, and then teach you one concept, one beautiful concept. So please, let's write as quickly as possible. So what do we do here? We just equate, right? We solve. 2x plus 4 is equal to negative x plus 4. Move the x over, what do you have? 3x equals to 0 because we moved that 4 over to give me 0. X is 0 over 3. Done. Now y is equal to what? Negative x plus 4. Substitute. What's your answer? So what's the coordinate of A? My grade 11s, are we okay? Oh, thank you, Fatima. Are we okay, everybody? Point of intersection. Are we good? Everybody okay with that? Okay. Number 5. Very, very important. We would not have done anything if we don't do this. Equation of a line. This you would need in analytical. You would also need in function. How do we get the equation of a line? First, y is equal to what? mx plus c. Steps. Number 1, find m, which we have done. y2 minus y1 over x2 minus x1. 2, solve x, y, m in y equals to mx plus c to get c. 3 sub m and c in y equals to mx plus c. We're done. I'll do the 3 steps for you. Oh. One, find m. 2, sub m and x sub m x y in this equation of your gradient, changing y over changing x. Let's say y2 minus y1 and simplify. I will use both methods. Sub m, let's say x1, let me say y minus y1, x minus x1, make it simple. Sub m, x1, y1 in and simplify. All right, my good learners, we want to try one line quickly. ST, -2 and 8, 3 and 2, because I'm coming down. All right. Whatever we did in grade 10 is the same, so I'm just reminding you guys of what we did. Let's follow the steps. We are going to do both methods, method 1 and method 2. But in both methods, gradient is the same. We have to find gradient. So I'm doing that. That is common. And then I'll break into method 1 and method 2. Gradient of ST, what is it? YS minus YT over MS, over XS. Now, what is the Y value of S? 8. What is the Y value of that? My gradient should be negative. Always have that expectation. The line is decreasing, so that if you make a mistake, you can deal with it. What is the X value of S? -2. And the X value of T? 3. So what is my answer? I have 6 over -5. So -6 over 5. Have an expectation, so that if there's a mistake, we can deal with it. Are we okay with my gradient? Do you agree with my answer? 8 minus 2 is 6. -2 minus 3, -5. But if we divide, all right, you agree. Beautiful. Now I'm using method number 1. Sub x, y, and m. So y equals to mx. I can choose any. I can choose either s or t using point S. It doesn't matter. We know our x and we know our y. Our y is 8. My m, -6 over 5. What is my x? My x is -2 plus c. We do the maths. That will give us what? 12 over 5 plus c. Move that there. So c equals to what? 8 minus 12. over 5. And what would that give us? What would that give us? What is 40 minus 12? 28 over 5. Confirm for me. (28/5). Thank you for those that confirmed. So what's my equation? Y equals to, I'm going to substitute my point 3. Substitute only M and C. What is my M? Negative 6/5 plus, what is my C? If I were to use point T, I'll get the same answer. But I want to do the second method. Or find M. We are done with M. Now check this. Y minus Y1. Okay, here I'm going to use point T. Here using point T. What is point T? Just to check. What is my gradient? Negative 6/5 y minus, what is my yt? 2 over x minus, what is my x value of t? 3. Let's cross multiply, everybody. So we have 5 into y minus 2 equals to negative 6 into x minus 3. I hope that makes sense. If you want, you can expand, which I would do, but it's fine. Minus 6x minus minus positive 18. Let's move the 10 over. Now, if I move the 10 over, it becomes positive 10. 18 plus 10, 28. Now, let's divide everything by 5. Plus. Do you see I have the same answer? I have the same answer. Everybody okay? This is grade 10. There's only one new thing that we did so far. Only one. The rest is revision. The rest is revision. Only one new thing, which is angle of inclination. Please, equation of the line is very, very important. Very, very important. I have two things I quickly work. Can I touch on two things? The other one is a note that I should give you. Or I can look at that in our next session. But are we okay so far? Did everything make sense? Did everything make sense to you? Okay, I want to do something now quickly. I'm going to do something now quickly. Just give me a minute. Okay, let me do this as my last point for the day today. Application of gradient. I want you to watch this. Application of gradient. If I give you parallel lines, two parallel lines, I hope my coordinates are just going to work well for me, but I've tried to cook them. I didn't calculate, but I was cooking while you guys were writing. Okay. And this can only work if these two lines are parallel to each other, and this one also parallel. -1 and 2 here. Okay, then let's move. My x value would move 1, 6. Yeah, let's see. Now let's move 4 units. 5. Move 2 units up here. 8. And I want x and y. Just a quick one. I wanted to see something very, very beautiful here. And then I'll just see. I need to end with properties. Properties of quadrilaterals. Okay, my good learners. You can see that I have 2 pairs of opposite lines. Let's call it PQRS. How would I find the coordinate of R, of S? I want to find the coordinate of S, but I noticed that these lines are, please, I'm going to listen. I want to ask you to listen to this part. These 2 lines are parallel. Now, there are 2 ways of finding it. There are 3 ways of finding this. 3 ways. 3 ways. And I want us to walk through the 3 ways. I'll end my lesson here. Lesson 2, I'm going to start with properties. So I want us to find the coordinate of S and R. This is almost like a rhombus. What will be my method 1? Method 1 is to see S is a point of intersection. All right, I'm going to ask you to do some things for me. So here we're going to practice. Point of intersection between which line? QS and RS. I hope that is visible there. QS. So if I look at QS and RS, they intersect at S. So S becomes my point of intersection. And what did we say about the point of intersection? We can equate them. Now, everybody, I want us to get the equation of QS. This is going to be quite long, but interesting. You cannot get the equation of a line until you get the gradient. Right? But the question that I'm having here, my challenge is, do I know the gradient of QS? Do you think I can get the gradient of QS? Anybody? For me to get the gradient, I'm thinking y2 minus y1 over x2 minus x1. But fortunately, I don't have S. So what should I do? Anybody wants to help me here? Let's think. Yes, Michelle?
You can use the gradient of the line that's parallel to it.
Oh, we can use the what? Gradient of the line that is parallel to QS. Which line is that, by the way, Michelle?
That is PR.
PR, because we learned that when 2 lines are parallel, they have the same what? Gradient. Oh, sweet. You're so smart. Thank you. So, because QS is parallel to PR, we can actually say that the gradient of QS is the same. All right. May I ask everyone to calculate for me the gradient of PR? I just want an answer. Everybody, we're all practicing. My gradient, always have an expectation. Should it be positive or negative? Have an expectation before you start calculating. Start sharing your answers with me. All right, I am seeing people are getting half, which is correct. 8 minus 6 over 5 minus 1. So it's YP minus YR. So I'm doing all of this, my grade 11s, so that you can see. I don't want to rush. What is my Y value of P? 6. Y value of R? 8. X value of P? 1. And X value of R is 5. And that will be minus 2 over minus 4, and that is half. So it means the gradient of QS is half because the lines are parallel. Wow. Can I then get the equation of QS? Yes. Y equals to what? Mx. But please, I must use point Q. Don't go and use point PR. They don't have the same equation. They only have the same gradient. Not the same equation, but the same gradient. I'm using point Q, negative 1 and 2. What is my Y value? 2. Gradient is half, negative 1 plus C. What do I have here? Negative half. If you move it over to that side, what is C? So what's my equation? Y equals to, gradient is half, X plus 5 over 2. This one is very long, but we will do it. Everybody okay with my equation of a line, equation of QS? Please let me know. All right, my good learners, you then now find for me, once you're done, quickly, find the equation of RS. Find the equation. I'm not going to do this. I'm going to trust your answer. Find the equation of RS. Find the equation of RS. Let's see quickly if we get this done. Maybe I can just give you the notes so that content now, but right, a mess. Equation of RS. Take your time quickly, get it done for me. So we've applied our first rule of gradient. Equation of RS. Okay, it's also a positive line. Quasi is done. Ooh, you're in machine, Quasi. Can we confirm that Quasi is wrong? Okay, I have a different answer. Fatima is giving me a different answer. Okay, so there's something wrong. Please let both of us check. Quasi has 2x plus 4. Fatima is giving me 2x minus 2. Something is wrong somewhere. There's someone giving me a wrong answer. So we are counting on others. Oratile, 2x minus 2. Linda Kutle 2x minus 2. Shandu Nolutando. All right. Ndubo is agreeing with 2x. Oh, guys, I'm seeing two answers. There's 2x plus 4 and 2x minus 2. How can that be? Kanjani, the class is now divided. Kanjani. Kian, what's your own answer? I've not seen an answer from you today. You are going to be the deal breaker. What's the answer? Kanjani. Guys, do I really have to do this? Yes, Michelle?
So either way, when I use both of the coordinates, I get 4. I tried both of them.
Okay, so who's talking to me? Is that Michelle?
Yes, sir.
So Michelle, you agree with 2x plus 4?
Yes, sir, because I tried both.
Crazy is there dancing on the table. I can see. He's giving us sound. But guys, Fatima, what happened? Why are you getting 2x minus 2? Kian, 2x minus 2. What's a guan? Come on. Yes, Fatima, talk to me.
So first I calculated the gradient of PQ.
Okay, so we all agree that gradient of PQ is what? 2, right?
Yes.
Okay, gradient of PQ is 2. You sure? 6 minus 2 is 4, and then 1 minus 2 is 2. 4 by 2. Yes, correct. Then what did you do?
Then I substituted the 2 into y is equal to 2x plus c.
But wait, which equation are we looking for?
RS.
Now, do you notice P and Q are not on RS? Yes. Okay, see. We are looking for the equation of RS. So we need the gradient of RS and a point R or S.
So would all the gradients equal because they're parallel?
Absolutely. My gradient is equal. But which point am I using?
5 and 8.
We have to use point R because we are looking for the equation of RS. Do we agree now? The gradients are equal, but the equations are not the same. So, let's see. 8 equals, probably that's where most of us are making mistake. And I did mention that. 2, 5, plus C. 8 equals to 10. C is, oh, you are correct. Those of you that got plus 4, can you see your error? You were using P and Q. We are not looking for the equation of PQ. We are looking for the equation of RS. We were only using that gradient and we transferred it. Come on. Oh, crazy. Jump down from the table now. You got it wrong, puppy. But did it make sense? Is that error taken? Let me show you laughing. Is that error taken? All right. They have the same gradient, but not the same equation. That's why we only use the gradient and transfer the value of the gradient. All right. Okay. Good. We are all now okay. So we have these two. Please take note of that error, and I'm glad we quickly picked up that error, and I did mention that. We have these two lines now. We have these two equations. And point S is a point of intersection. What do? We equate. Please, let's equate them and find the value now. So I'm just coming from there. I don't want to move from this page. So what do? We equate 1 over 2x plus 5 over 2 equals to 2x minus 2. Please get me a value for x. Let's do the maths. We move all the x to one side, we move all the y to one side. I just need an answer for x. Anybody? Value of x? Oh, this is so long. It's taking our time, but it's good. We're learning and picking up a few mistakes. All right. Keep working. 1 over 2x minus 2x minus 2 minus 5 over 2. What would that give me? Minus 3 over 2. And that will give me what? Minus 9 over 2. Am I right? Are you getting 3? Are you getting x as 3? Crazy, what's wrong now, Crazy? So if x is 3, what is the value of y? We just substitute in any of the equations, right? Let's substitute in the one without a fraction. 5 minus 2. I'm lying. 6 minus 2 is 4. So what is the coordinate of S? All right, such a long process, method number 1. But we got the answer. Are we okay with method number 1? So we are applying our gradient at the point of intersection. That's why I call it application of gradient. I found my 2 equations, and it's important, that mistake that we saw, you are only transferring the gradient. You must use the point on the line that you're looking for. Method number 1 is done. Can I jump to method number 2 quickly? Such a good lesson today. I enjoyed the content. Anybody still busy writing? Give me a thumbs down. I want to move, but give me a thumbs down if you don't want me to move yet. Okay, Lino. You give me a thumbs up when you're done. Don't forget to give me a thumbs up, Leno. I'm waiting for you. Oh, you finished and you were chilling. Oh. All right. Method number 2. Very, very important. Method number 2. Now, with the way this thing is, it is a rhombus. And this is what I am going to use. I am going to use midpoint. If I draw a line there, and this is the last note I wanted to give you, I'm going to give you the properties that you should know. Midpoint. The midpoint of QR is also the midpoint of PS. This is midpoint. It's the property of shapes that are very important. We did that in grade 8, 9, 10. Midpoint of RQ is also the same as the midpoint of PS. So I think for now, using RQ, we can get the midpoint, capital M, don't forget, of RQ will be what? XR plus XQ over 2 YR plus YQ over 2. Midpoint. Give you a moment to quickly write that, and you can also go ahead and calculate. Midpoint. What is XR? 5. XQ? -1. What is YR? 8. What is YQ? 2. So what would that give us? 2 and 5. Did somebody do it individually and you got the same answer? You were not copying. If you were not copying and you did on your own, thank you, Rati. Oh, so that is now the midpoint of P and S. Oh, sweet. So I know my M already. Then I know that X of M is XP plus XS. We did this earlier on, right? I know the midpoint and I'm looking for the other side. My midpoint value is 2. Do I know XP? 1. Do I know XS? No. Over 2. Let's cross multiply. 1 plus XS equals to 4. What is the X value of point S? 4 minus 1 is 3. Okay. What about the Y value? Y of the midpoint. Please don't forget it's capital M. Will be what? Y value of P plus the Y value of S over 2. What's the Y value? 5. What's our Y value of P? 6 plus, we don't know this one. 6 plus YS, 10. 10 minus 6, 4. Oh, so what's the coordinate of S? I think it was the same thing we got, right? 3 and 4. Okay, this is shorter, but only because we know the properties of a rhombus, which I'll be giving to you. I'll give you that note. Not today. Time is up already. But I said there are 3 methods. Are you okay with my method number 2? Midpoint formula. So the next note I'm going to give you is very, very important. It is about properties. And you can Google it already for me if you can. Properties of quadrilaterals, parallelograms, and all of those. Okay. Please write as quickly as possible. I'm ready for my third point, which would be the closure. If you are still writing, give me a thumbs down. Should I move? Yes or no? Let's see. Anybody giving me a thumbs down? Not yet. 5 seconds for you. 5, 4, 3, 2, 1, and 0. Yay! Okay, we move. Last part. Now, this is my application of gradient. This one, I need you to listen carefully. My good learners, now watch this. Oh, let me clean this gradient that I wrote. There we go. Please watch this. I'm going to do this for you in two ways. I am going to consider point P and point Q. I am considering point P and point Q. And the easiest way is to do this. If I were to draw a vertical line here, all right, and a horizontal line there. Vertical line and horizontal line. Look at my x values, guys. My x value here is 1. And my x value here is -1. Please watch again. I'm using point P and Q. From -1, okay, let me do this. X value here is -1 and the x value here is 1. Are you seeing that, right? X value is -1 and here is 1. How many units did I move? From -1 to 1. How many units did I move? This is very important. I need us to get this. I'm looking at I'm using P and Q, right? The x value of Q is -1. The x value of P is 1. Moving from left to right, how many units? 2 units. Because I move from -1 to 0, then 0 to 1. So it's 2 units. Does that make sense? Are you okay with my 2 units? -1 to 0, 0 to 1. 2 units. It means that the difference between R and S is also 2 units. Horizontal line there is also 2 units. So if my value here is 5, what do you think the value here would be? Talk to me. It's 2 units. The value on the right hand side is 5. What is the 2 units before 5? Please let me know if I'm losing you. I'm not getting an answer from you. It means you guys are lost. Again, check. Considering the X movement, I'm using P and Q. Do you see that? The X value here is -1. The X value here is 1. So I've moved 2 units. Okay. Now, the same 2 units. If this is 5, 2 units before 5, what should that be? 3. Do you understand my 3? I'm not getting any response from anybody. It means we are lost. Please talk to me. Who is lost with my 3? It is 2 units before. Here I am not even calculating anything. And I'll do this in 2 ways. So already I'm done. Coordinate of S is 3. What about the Y value? Again, I'm using P and Q. What is the Y value of Q? 2. What is the Y value of P? 4. Do you notice I have 2 here, Y value, and I have 6 here. Oh, I said 4, 6. What's the difference? From P to Q is either you come down or you go up. Anyway, if I'm coming down, how many units should I need to come down? 4 units. Does that make sense? From top 6 down 2 units. I need to come down how many units? 4. Can we come here to R and also come down 4 units? What is 8 minus 4? 4. And I'm done. I don't calculate. All of those things I was doing method 1. Check. I'm already done with my answer. 3 and 4. Did that make sense? Please, did that make sense? I want to use another set of coordinates now. Did that make sense? I am not calculating. It's full marks, people. Full marks. You get full marks. In case you are lost, please watch this. In case you are lost, I want to use another 2 sets of points to prove to you what I have done. I'm cleaning everything again, and then you can practice this. I'm cleaning everything again. All right, cleaning that again. Let us use P and R. I want to use P and R right now. What is the X value of P? 1. What is the X value of R? 5. Do you notice I am moving to the right by how many units? From 1. Units you just subtract. What is 5 minus 1? 4 units. Does that make sense? X value of P to X value of R, 4 units. Does that make sense? 1 to 5. You're just counting 1 to... Basically, you say 5 minus 1, right minus left. Can I come here and move 5 units as well? 4 units. Just add. What is negative 1 plus 4? That is what? 3. So I'm done. S is 3. Does that make sense? X is 3. Let's go back to P and R. That's my source. What is the Y value of P? 6. What is the Y value of R? 8. Do you notice I'm going up? It's just 6 plus 2 to give me 8, right? I'm going up 2 units. Come here and go on. Now the Y value. You added 2 there. Add 2 here as well. Y value. Move up by 2 units. 2 plus 2. 4. S is 3 and 4. Check. Same answer. Same answer. I want to take your questions quickly. We are out of time, but is there anyone who is lost at any particular point? If you are okay with the entire lesson, give me a thumbs up. So we are using gradients, method 3. We are using movements of gradients. Everyone looks okay? And can I show you something nice? Let me just show you something nice as I finish this one. Do you notice? Wait, let me show you something nice quickly. Just to see something here. This is P, right? And this is what? R. We said 1 and 6. We said 5 and 8. For the horizontal movement, we were moving what? 4 units. And for the vertical movement, we're moving what? 2 units, right? Do you see that? From 6 to 8 is 2 units. From what? Guys, what is my gradient? If you can see here. Change in Y over change in X. What's my Y? 2 over 4. Do you remember the gradient was half? So you guys remember? So gradient is your change in Y over change in X. So we are changing the Y values by 2 and changing the X values by 4. Do you remember the gradient of PR was half? If you go back, it's there. We did that. Gradient of PR. It was half. Yep, the first one. Half. And if you check this one, I was using PQ, right? Again, let me quickly draw out PQ for this one. I was using just to show you gradient. Q and P. 1 to 6, negative 1 to 2. What was the movement to the right? From negative 1 to 1, it was 2 units. And from 2 to 6, it was 4 units. Was my gradient. The change in Y, it changed by 4 units. By the change in X. Done. Gradient of PQ. It's 2. I am done with my lesson. No questions, I believe. You guys all give me thumbs up. Beautiful lesson. Guys, grade 11 is just done. Content is all done. What's remaining is to look at what properties. So guys, those of you that are in grade 12, this is question 3. Already we're done. One more session, we do activities, and then we move to the next topic. Analytical, done. To what? Which page, ma? The one? This one?
No.
This one?
Yes.
Vera, talk to me. Vera, your hand is raised.
Can you please go back to the slide where the point of intersection?
Okay, we'll do just now. Ndugu, are you done with this page? Ndugu, you're done? Okay, Vera, is it the notes or the calculation? Which one?
No,
This one?
the notes. Yes, sir.
Okay.
Thank you, sir.
All right. No other question, right? Have a lovely evening, everybody. That was such a splendid session that we had. Analytical geometry, lesson 1 done and dusted. Beautiful lesson. I love it. Lesson is available on the link provided in the group. Goodbye.
Thank you, sir.
Pleasure. Bye, Kwezi. Bye, Tando.
Can I ask you which link? Because you didn't get the link even last week.
Okay, I'll resend it and I'll pin it for you. Okay.
Please.
Yes, ma'am.